There we are. Welcome, everybody. I'm here with Falk Sipak, which will talk about one of the most interesting features that are incoming in Java, which is value objects. And this is really interesting. One second, I have a return here. Okay. One second. What's going on?
Doesn't matter.
It's this one. No. Sorry. It was my fault. Sorry for this mess up. Okay, so we're good now. So I was saying Falk is actually a local Java user group leader in Darmstadt, Germany. So if you're close to that area, Frankfurt in Darmstadt, and you want to contact him for local Java user group, especially if you want to present something interesting at the Darmstadt Java user group, that would be great. He's also a conference organizer for the JavaLand conference in Germany. And he has been working as a software architect and a consultant and trainer as well in the Java space. So without any further delay, I think I will give him his time for the session. So let's switch to this mode and I will get out of the way. So Falk, the stage is yours.
Thank you very much. Hello, everybody. I'm very happy to be here at JChampions conference and want to talk about value objects, the next big thing in Java. And as Simon already told us, I'm also a leader of a local Java user group. It's JUG Darmstadt. And if you're next by, then just come to us on February 19th. It's in about 4 weeks, I think. There we have free talks, different talks. Just go to the webpage and have a look. And there is another kind of online community in Germany. We call it Cyberland. And there we have sometimes also events, online events in the evenings. But there are, at the moment, there are monthly open source code camps like Hacker Garden. And if you're interested and want to implement some cool open source stuff or stuff for open source projects, just come by. So let's come to the real topic, and we want to talk about the big next big thing in Java, value objects. And there are quite a few incubator projects in the JDK, in the open JDK, like Ember, where the pattern matching, for example, was implemented and is still in progress, or like Panama, where Vector API, which is still in progress because of value objects, but also foreign function and memory API, which is already finished. Then there's Project Loom with the virtual threads and Project Leiden with different initiatives for faster startup time and time to peak performance and less memory footprint. And there's value types or value objects which are implemented in, it's called Valhalla, Project Valhalla. What does Valhalla mean? It's from the Nordic mythology. It means Hall of the Fallen Warriors. And I asked ChatGPT why is it called Valhalla in Java? I don't know if it's right, but he said, or she said, or whatever, that is because of value, and so Valhalla is the Hall of Values. So could be, but I don't know. Maybe we should ask Brian Götz or some other people from Oracle. But I hadn't the chance to ask them. So first of all, I will give you a short introduction about this project Valhalla. Then we will talk about the primitives versus objects, object references. Then we will see how value objects will look like in maybe next year. We will get them the first time. And we will talk about some other stuff which will come with value objects or afterwards when value objects were introduced, and some summary at the end. Yeah, let's start with the project web page, and they have a kind of slogan. They say they want to combine the abstractions of object-oriented programming with the performance characteristics of simple primitives. And in short, I think that's the most known sentence in the project Valhalla. Codes like a class, works like an int. So you can define your own classes, but they are efficient like a primitive int, for example. And yeah, Brian Götz is one of the architects of the OpenJDK, and he said to Valhalla or to the value objects, it's Java's epic refactor. So it's a key deep cut through the user model, through the language, to the Java platform, to the Java virtual machine. And that's the reason why it's still in the making, and it's about 10 years now, or more than 10 years now in the making. Yeah, there's the URL to go to the project, and there are some there are some more informations, and we will talk about it. For example, there are already a few JEPs. JEP is JDK enhancement proposal. So a few features are already delivered, got delivered in the last years. A few were for Java 11, 12, one for Java 15, and the last one for Java 16. Let's have a look. What is it about? There was JEP 181. It's about nest-based access control. And there's new concept in the bytecode to access private members between classes, so-called nests, nestmates. So that's about nest-based access control. Then there's the dynamic class file constants. That's a new bytecode mechanism, constant dynamic. And it helps to have a more efficient generation and caching at runtime, something like lazy initialization in the bytecode, for example. Then there's the JVM constants API. So it's an API in the OpenJDK to access have a type safe access of constants in bytecode. And it's also kind of a pre-work for value objects. And then there's hidden classes. There are hidden classes that are created at runtime, but should not be referenced from regular code. And that also helps to have some things which we need for value objects in the bytecode, which should not be used from the regular code, for example. And the last one is about warnings for value-based classes. And that's about that we always have kind of value types already in Java. So that are normal classes which behave like values, which we will talk about values later. Values are, for example, integer, optional, local datetime. So they are most of the time immutable. They have no identity. They can be compared via equals. And if we have such classes, we already have a view of them or lots of them in the JDK, then if we use them the wrong way, then we get warnings since JEP 390. It's from Java 16 or OpenJDK 16. And there's the last one, which actually is not really a part of the project Valhalla, but also pays into the project Valhalla to value objects, sorry. And it's about flexible constructor bodies. And it's about avoid larval states. Flexible constructor bodies was finalized in Java 25, so a few months ago. And it's about statements before the super or this statement in constructors. And that's important for value objects because they don't have identity. So they have to be initialized consistent, and we need some special care for initialization. And they call it larval if an object which is being constructed is not yet fully formed. And that's the reason that we need flexible constructor bodies also for the value objects so that they can be sure that they are fully initialized before we use them. Okay, that's about the project Valhalla and some pre-work. And now let's come to the primitive types versus objects. And that's one of the legacies of Java. Of course, Java is an object-oriented programming language, and we always have objects and object references. But in the beginning, 30 years ago, Java is now more than 30 years old. They also introduced primitive types mostly because of efficiency reasons, because object references are quite slow, as we will see in a few minutes. And we have both. We have primitive types, we have objects, and we need something in between. And this bridge will be value objects. So let's start with some examples. And there I have an integer int variable. It's only with the value 1, 2, 3, 4, 5. And yeah, just a declaration of an integer, a primitive int. And actually, that will be stored on the stack. Yeah, we have stack and we have a heap, and it's called in the stack, so there's no heap memory required. And the big question here is, what is E all about? What does it mean? So E in German, I in English, and actually it could be a zip code, and that's a better name than I. And the problem here is it's still not type safe. It's still a so-called primitive obsession. That's one of the code smells Martin Fowler introduced in his book Refactoring. And code smells are parts in my code which could be improved, which could be refactored. And primitive obsession means we always use a simple primitive types like int, like double, like boolean. And for me, it's still also string, which is actually not a primitive type, but it's a built-in type without meaning. String can be everything, and as an int as well. But most of the time, we have a zip code, we have an email address, we have a name, we have a street or whatever, and it has a meaning, and we can't see it when we look at the type. We can only see it if we have a good name. And we all know naming is one of the hardest things in the IT. To find good names is always difficult. And actually, we won't use zip codes as one value. So let's use it in a combination, like in an address, and it's just an int parameter or an int member variable. And it's still primitive obsession because we still use int. And for example, if we have a house number and a zip code, then it could be quite easily to mix things up and just use the wrong value for the wrong place. And then that could be some ugly runtime errors which can occur later on. So we just saw the primitive types, and now we want to come to the object references. We'll see some more examples. Primitive types actually are handled very efficiently. They are just they are stored on the stack. The stack is where my program statements are just stored and kept and just used, and there will be the primitive values are also stored there. And on the other hand, there is the heap. Heap is where my objects are living. There is garbage collection, which tries to tidy up and delete some of the memory which is not used anymore, but it's a bit more work to keep it clean. And I want to do some to compare some numbers. And actually, I'm not an expert in memory layout of Java, so I just asked GenAI, I just asked ChatGPT, and I got some help, for example, from Johannes Bechberger. He's also from Germany. He is working for SAP and has some more insights in Java and Java memory layout, and he helped me a bit. So let's start with a very small int I with the value for 42. And actually, that's just 4 byte. So int is 4 byte, and it needs 4 byte on the stack. When we use it and it's not used anymore, then it will be just thrown away, and the memory will be freed up again. And on the other hand, we could have a point which has two int values, x and y, and then we initialize the point with 1 and 1. And now we have a reference on the stack, which is just a pointer to my object. The object is in the heap, and there we have a header. Then we have the two values, and we have some more overhead, as we see in a moment. There's, for the reference, we have 8 byte, or if it's compressed, we have 4 bytes. And then we have the object with a header of 12 bytes, and we have 2 times 4 byte for x and y. And then we still have so-called padding. I just speak about or talk about padding in a few seconds. And in the sum, we have 24 bytes instead of 8 bytes. So if we have x and y as 2 ints, then we just have 8 bytes. And now we have about factor of 3, 24 bytes. So what is padding? Modern processors work more efficiently when the data starts at certain memory addresses, and that should be a multiple of 8 bytes. So we have to fill up if our object doesn't have a size of which is not divisible by 8, then we have to fill it up. So we can't have 20 bytes. We need 24 bytes in that case. So let's make a bit bigger example, and there we have a list of points. And there are just a view now. It's an array of about 6 or 7 points, 6 points here with the coordinates. But let's think about it could be millions of points. But millions of points wouldn't have fit on the slide. So just an example. And there are different possible implementations for it. The most efficient, but maybe not that easy to maintain, would be we have 2 int arrays, x's and y's. And the other one would be more like the real model. We have an array of so-called point objects. And let's see how big is the difference between the two memory layouts. And if we have the one with the x and y arrays, then it's just a header for the int array. It's about 12 byte. And then we have 10 times for 10 values, 10 times 4 bytes, and some padding. And in the sum, we have 112 bytes. And otherwise, on the other hand, when we use just a class point with x and y, and then we have a point array of 10 points, and just think about 1 million or 100 of millions of points, but here we have just 10. Then there would be a reference to the point array, which is on the stack, which has 4 or 8 bytes. And then we have the point array for itself. It has a header of 12 bytes, and then it has 10 references to 10 points, so more at 40 bytes. And then there's still the length of the array with 4 bytes. But then each reference still has or points to the actual point, which has 24 bytes again. And so there will be about 300 bytes. So it's about factor of 3 again. And that's quite a big difference. And it's in that case, it's not very efficient because everything on the heap costs more time to access, and there are some caches involved, and there's also garbage collection involved, and everything on the stack is much more efficient than if the objects are on the heap. They are stored on the heap. So let's see the same example now for value objects. And the same example would be that we have a value class or a value record of point. So both is possible. And that's actually the whole implementation of value objects. We just have this keyword value in front of record or in front of class. And it doesn't matter if we use class or point in that case. So the difference between class and record is that class is just the normal class, as we know already since 30 years. And records is there since a few years. It's a immutable data carrier. So we see the elements of a record and it's public. So that's the difference. And there will be some more generation of things like the constructor, toString, hash code equals. Yeah, that's the boilerplate code, which will record save for us, so we don't have to write it on our own. And I will use a record here. So we have a value record point with X and Y. And then I initialize 10 points in an array and just have 10 points with null 0, 0, 1, 1, 2, 2, and so on. And now let's see how big are they. And there's a reference for a point, which of course still has object on the heap, which has a header and X and Y. That's because of value object doesn't mean that they always are stored at the stack, but they could be stored on a stack. So when they are stored on a stack, then they are just two values, X and Y in a row. Yes.
Sorry to interrupt you, but we lost the track of your slides. I don't know if you unshared them, or can you please reshare them? So
yeah, of course. Sorry for that. I will just reshare them. I didn't recognize. Thanks for mentioning. So they should be back again. Can you see it?
Yes, I can.
Sorry for that.
No problem.
Magic.
No problem.
I don't know why it's got lost.
It's all set up now. Okay.
No problem.
Leave it to you again.
Thank you. So the JVM can just store them on the stack and just flatten them. So they are just values and there's no header, there's no padding. And that's the reason why it's cheaper and more memory efficient. And here we see some more examples. So the first two rows we already saw. And now we have the point array with value objects or value types. It's just 96 bytes. So it's almost optimal. It's also smaller than the two int arrays because we have only one array. And if we use an array list of points, then it's about 320. And if we have an array list of point value objects, then it's also nearly the same like two int arrays. It's 128. So it's, the numbers are generated by GenAI, so maybe they are not exactly the right ones, but I think it shows that we can save some memory. Yeah? That's one of the important advantages. It's not the importance one, but it's one of the advantages we can have when we use value objects in a few years, when we can use them. And what can we save? It's maybe it depends. So I said here up to 50% less memory. It can be more. So it depends which memory or which objects I store in my memory. But there are some more important side effects like faster direct access as the data is closer to the CPU. There are no caches which were involved when we have the data on the heap. And heap is always more expensive to access. And they are getting removed. So they were automatically removed from the stack if they are not used anymore. So there will be no garbage collection for these value objects. And that's also, can be quite helpful. And here I have another example. It's from a German newspaper article. So sorry for the footer there. That's the name or it's the title of this article. So if you are speaking German and have access to the German Java magazine, then just have a look. But I really like this example. It's a bit more complex. And one example which shows that there's more than half of you can save more than half of the memory. And we have a rig pixel here. A pixel has a position and it had a color with alpha value. And the position is just like a point when we saw. And then we have the color, which is a RGB, and it has a byte for alpha, for the transparency. And RGB is just 3 bytes are red, green, and blue. And yeah, you can see the visualization here. And that's about 96 bytes. And if we just use value records, and he can flatten it, the JVM can flatten it, then we have just 12 bytes, because we only have 2 ints, and that's 8 bytes, and then we have 4 bytes, which are only 1 byte, and then it's just 12 bytes. And that's factor of 8, about 8, so that's quite efficient, I think, but it depends. So it can be, I would say, yeah, maybe half of the memory, can save half of the memory if we use value objects instead of normal object references or objects. So what are value objects all about? Value types, actually, it's only this small keyword value. Everything else is still the same. They are, the classes are final, the fields are final, so they are mutable. And we can also use or can implement certain interfaces. The value classes have no identity. We will talk about identity in a few seconds. And you can use equals equals to compare your value objects. And hash code and equals equals are implemented for us, and they don't use the memory address. They just use the content of our value objects. And because we don't have identity, we don't have header, there is no synchronization, but we don't use them that a lot, I think, or I've never used synchronization in most of my use cases, but it's not allowed here. And of course, JVM, Java Virtual Machine, can, but does not have to and will not do it in the beginning, but it can optimize memory out and performance, and that will help us to have some more efficient Java applications in the future, maybe in the next 10 years, not in the next 2 years, but maybe in the next 5 or 10 years. And if we use more and more value objects when they got introduced, then the JVM will optimize it more and more from version to version. And as you see in this example for point, of course, we can have methods. So there's a move by method here. And actually, they look like normal classes, but are value objects, and they are not stored as objects. They are stored as, or can be stored as just values in the stack, for example, so more memory efficient. And there they say they have no identity. What does that mean? Why don't they have an identity? And I think identity is in this example, if you have twins, they look the same, like we use equals, and they have the same color of hair color, they have the same eyes, the same mouth, the same t-shirt, and so on. But they are not identical, like in equals equals, so they are still 2 persons. They have 99% are the same, but there are some small differences, and so they are not identical, and that's the difference. And if we have a look at the memory layout again, then we have a reference P1, which points to a class point or object point with X and Y with a header. And then we have a second reference, which points to the same object in the memory. Then, of course, we have an identical object. We have the same memory address. And then we have a reference P3, which points to another point with the same values. But of course, then it's not identical, but they are equal because X and Y are the same, have the same values. So that's maybe also helpful to understand. The goals for object identity is that we have to identify our objects. So we need identity if we want to identify the objects later on. So we can't compare them by their content, by their values, or we have to compare them with their reference where the object is stored in a memory, and that helps us, or that enables mutability, so we can edit our objects. We don't use that much, or we should use the mutability, but sometimes we have to use it or we need it. And if we have concurrency or we need concurrency, then we could use locking mechanisms, synchronization. The monitor is part of the header of the object, but most of the time we won't need synchronization. And the problem with object identity, that are the consequences, the disadvantages, is that the memory usage is not very efficient, and it's not possible to have a very dense memory allocation. And we have lots of indirect references and have, of course, a fragmentation in the memory. And there are also some unexpected, there's some unexpected behavior if we use equals equals. Of course, two objects which have the same values are not equals or not equals equals meaning they're not identical because they are different objects in the heap memory. And so we have two concepts with object identity. We have equals equals and we have equals the method, and that's always a problem and some source of problems at runtime. And let's see what does dense and flat mean. So if we have a reference of a point array, then we have on the stack we have our reference. On the heap there's our array, which has a header, which actually references the points, which is not flattened. If we want to have dense, very dense and flat memory layout, then there would be just the array with the header, and there where the reference to the first point would be just the two values, 1 and 1, and the second place they have the second values 2 and 2, and that would be much cheaper and more easier to access. And that's heap flattening and scalarization. That are the two possible optimizations which the JVM can adapt if we have value objects sometime, maybe next year. That's it about value objects, but we have still some time left and want to look at what is coming as well with value objects, because there are some more issues to solve. And value objects will be part of the CHAP 401. And I had maybe 1.5 years ago, Brian Goetz already said after 10 years they reached the top, and they now know how to implement value objects. And I thought, cool, let's start and have a look how they will work. And I was hoping that they are already part of Java 25 last year, but of course that was too optimistic. They were not part of Java 25. They, of course, won't be part of Java 26, which is already freezed. There will be no new features in Java 26, which will be released in March. And I also think they won't be part of Java 27 this year in September, but there are the first signs that it will be part of Java 28. So let's see, maybe next year in March, and I think we will see it in September this year. There will be the first merge commits in the OpenJDK code base, and then we can just see how it works and what is where the problems are and so on. So that is the part we already saw. Then there are some more CHAP drafts. There is CHAP draft which has no number yet. It's about null restricted types. We will talk about it in a few seconds. Then there's a second CHAP draft. It's about null restricted value types. There's a difference, we'll see. And there's another CHAP, it's 402. It's about enhanced primitive boxing. It's about we want to use the value objects inside or as generic parameters in our collections, for example. And there will be some more. We don't know yet, but I think in the next few years, so maybe next year, they start with value classes, and then each further year they will introduce some more concepts like null restricted types, like enhanced primitive boxing, and there will be some more we don't know yet. So let's have a look what is null restricted types all about. And the question is, if we have a value class point with x and y, can a reference p from type point, can it be null? And of course it can, but why? Yeah, and the reason is we need backward compatibility. Java is still backward compatible, or should be, and the class point could have an interface which it implements, and there could be a non-value class or an identity class which also implements the interface, and the reference from this interface type, the different implementations should behave the same. So it can't be the one can't be that the one is null and the other one not. So backward compatibility is still a problem. Also, that we want to have a uniform object model between the different types, between the value objects and the identity objects. And that's the part codes like a class, works like an int. Then the big problem also is if we have some null, or if we don't have null, then we need some default values for initialization of our points, for example. And for int, it's easy, it's just 0. It could be 0, but what's for example, the default value for string, or for example, for a date or local date time or whatever? That's a bit more problematic because it's a business problem then, and there's no possibility to have some default, to define default values for value class at the moment. And there is some time where we have both concepts, and they have to dismantle it sometime in a few years, and that should still be possible. So that's also the reason for it. And the goals for null restricted types, and actually it's not only for value types, it's for every type in Java. So every type object reference could be declared non-nullable. And the goals for it is that we have, of course, type safety. The compiler already can warn us if something is wrong, and we won't get, hopefully, no null point exceptions anymore. Of course, that won't work because of backward compatibility, but in the future, there should be less null point exceptions. And we, of course, with this concept of explicitly declare nullability, we want to make visible in our code that some types or some references can be null and some could not allowed to be null. And there could be warnings during conversions, like in generics in Java. We already have since Java 5. And of course, it has to be interoperable with legacy codes. And the solution could look like this one. And some of you already know Kotlin. And in Kotlin, there are some similar concepts. In Kotlin, every type or every reference is not allowed to be null. Otherwise, if you have point question mark, and of course, if we have point without exclamation or question mark, then it's the behavior as before. It's still nullable, but we can have a exclamation mark. Then point exclamation mark means null is not allowed, and point question mark means null is allowed. And that's the readability. You can see which is allowed, which not, and the compiler can help us. And we can have null checks during compilation phase and so on. Yeah, that's the chap with the null restricted types, which we will get for every object reference, not only for value types, also for the identity objects. And that was really cool. And the reason is that afterwards, they have the second chap draft, null restricted value types. And there, for example, we could have a point array. And point in that case, of course, should be a value type, or is a value type. And this is null restricted. And then if we have null restricted point or value type references, then the JVM know there won't be null values, and they can just flatten it. If we have the null values, then it needs at least one bit more to say it's null or not. And that wouldn't work. So, for example, for int, if you have 4 bytes, then we need 8 bytes only for 1 bit because I want to say if it's nullable or not. Null is allowed, and that's no good idea. So if we have the null restricted types, we can also have null restricted value types, and then the flattening and make a more dense memory layout is possible. In that case, we have an array maybe on the stack with just 100 points, and each point is just the x and the y value, and then the second one, the third one, and so on. And that's very efficient then. So the idea is that we avoid null checks at runtime, for example, and that can, of course, save massive amounts of memory and improve CPU cache and performance hits and so on. And maybe it's just the future. I don't know if this example will come in that way, but we maybe could have kind of a null safe operator. We have some other programming languages, for example, in Groovy, I know it, that's called the Elvis operator. And then maybe user could be null. And if it's null, then we would get a null point exception. Otherwise, if it's null, then it just returns null and address will not be accessed. So kind of null safe operator could come with that implementation. Yeah, let's come to the last one, enhanced primitive boxing. And it's all about primitive types. Int, double should behave like reference types in even more situations. And each primitive type has already a boxing type. So int has an integer, double has the double in the first letter in big, and so on. And these primitive boxing types will be value types when value objects get introduced. And then they have this efficient memory layout and are very easy to use. And in that situation where we have to use primitive types, we could then use just the value types, and they behave like normal reference types. And of course, we can define our own types. We can have our own ints and strings with a meaning for email address, for postal code, zip code, and so on. And if there's some unboxing involved, then JVM can automatically perform that. And now we have, for example, some possibilities like we have an int I with the value of 12. And on I, we can just call a member constant size in that case, or could also be a method. And that was not possible before. We couldn't call any method on a primitive type, but actually it will be boxed to an integer, and integer is just as efficient like the primitive int because it's just a small value type then. And then we can just use all the methods, all the member variables which are for int defined. The same here for radius, and we can say power 2, or there we have a list of ints and a list of 1, 2, 3, and then we add 4, and then we can just get an int back. And of course, list is of integer, but there's an implicit boxing unboxing, but boxing unboxing it's not really expensive. It's not as expensive as it was before because it's just the same value, and the wrapper isn't anymore. There's no header, and so there's no identity, and so on. And here we have an int array with 1, 2, 3, and we can just assign that to an object array. And there's also a box view from int array to integer null restricted array in that case. And that's also behind the scenes, and we won't have to think about it. So that's it. We come to an end, and I hope you had a good idea, became a good idea how value objects will look like, and what are the consequences, and what are the advantages, and what is it about? We have final immutable data types. They are compared by their state, not by their identity. There is no synchronization, and JVM can optimize, flatten, interning, scalar replacement. And there are quite a few examples. I think in the last pre-release, which was released in October last year. They already transferred about 30 already existing classes like integer, local date, optional, and a few more. They already rebuilt them as value objects, and you already can use them or can try them. I will show you in a few minutes. Why is it a cool idea, or why are we waiting so long for value types? Because we can now have our own data types, value objects, like already, which are already were described in domain-driven design as objects without identity. They are just made from their values, so point with X and Y, for example. And we have come very cheap, very very easy. We can very easily define our own data types without the overhead of the object identity objects with header and padding and so on. And they can be saved or stored on the very close to our CPU on the stack, and then that helps us to, if we have very large data amounts of data, then it's also quite efficient to implement them and so on. Yeah, and there's a bridge between the primitive types and object reference types, and there's more of the primitive types can behave like a normal object type. We can have a list of int, for example. We have better performance, less memory consumption, and so on. And of course, value objects will be the next big thing. I think it's in a row with generics, with lambdas and stream API, with the platform module system, and with the virtual threads, and maybe a Java 28, beginning with Java 28. Maybe in the next LTS release, Java 29 will be the next LTS release. Then we already have value objects. It will take some time because there are quite a few things. They have to be implemented. They are not here. They are just in the thinking at the moment. But I think in the next 5 to 10 years, we will have value objects. And the big question is, Valhalla when? That's like a meme already. And when you ask Brian Götz this question, then he most of the time says, I don't know. I can't promise it is ready when it's ready. And we can already use it at the moment. The most easiest way is if you just use a J shell, which is usable in the browser. There is one from Oracle, but this one here is from Java Almanac. That's a cool reference about all the features which were implemented in the last Java versions, and you can just or see the difference between different Java versions. And they also have these Valhalla sandbox, and there you can just use value types and just play around. And you can use it by your own, on your own laptop. A long time there were no new pre-releases, and you had to build it on your own, and it's quite easy. I just tried it on my laptop. You just clone the OpenJDK Valhalla Git repo, and then you have to call two tools, bash configure and make images, and then you have fully JDK image on your hard disk about project Valhalla. And if you want to use it in your projects, then you have to put it in the Java home and in the path. But there's a very easy version or very easy tool which you can use. It's called SDKman. And SDKman has a cool feature where you can just install already existing JDKs which are on your hard disk. And here in that case, I install Java Valhalla, and there's the path where the image which I just built is which is where is it lying. And then you can just use it on the shell or on a J shell and can try Valhalla. And in October last year, there was a new article about Project Valhalla. It's on insight.java. And here you can see it. Actually, I forgot to put the link on the slide, but when you go to insight.java and just go a bit backwards, then you will see it. And they just announced a new early access build, so you don't have to build it on your own. You can just use that build, and it's from October, so it's quite current. And then you can also try it, and there are some more examples on that blog post, so just have a look. And there's also a YouTube video from Nikolai Parlok, who interviewed Brian Götz, so just have a look there. And that's it. If you want to have a look at the slides, just go to embark.de. It's the company I work for, and /download. There you have to go a bit backward because the slides are there from May last year from the JCon conference where I had the same talk. And otherwise, I can also, if you can contact me, and I can just send you the slides here, or maybe I can send it to the Champions Conference organizers, and they will publish them on the conference page. And at Embark, I've not talked about Embark. Embark is a small IT consultancy in Germany based in Hamburg. We are doing trainings and consultancy about software architecture. And we have some interesting material, cheat sheets like this one about documentation as code. That's actually only available in German at the moment. There will be an English version, but some of these cheat sheets are already translated to English. So maybe the architectural overview, architecture reviews, agile architecture, or lightweight software reviews. If you're interested in these cheat sheets, then just have a look at embark.de Architektur Spicker, and Spicker means cheat sheet in German. Yeah, and that's it. Thank you for being in my talk. If you have any questions, I'm looking forward to some discussions. And yeah, if you like, just add me on LinkedIn or follow me on Mastodon, X, and so on. Thank you very much.
Thank you, Falk. That was a great presentation. There are a few questions from the audience. I will highlight them, and then we can go through them. Not sure you will still be needing the slides, so I'm leaving them on for now, but then we can remove them later if it was. So there was quite a few jokes, like you could imagine, about when Valhalla is coming, and about the naming and stuff like that. But eventually, there's a comment here that says, well, Valhalla is amazing. I truly hope it gets released very soon. And the first question is about, one second, this one, which is, so it was made in the context of unboxing of primitive types along with their boxed counterparts. And I think you explained it later in the slides when you were talking about enhanced boxing. But yeah, just to confirm, fundamentally, Java lang integer will be a value type, and therefore it could be allocated on the stack.
As I understand at the moment, there will be a unboxing, but it's not that expensive because it's just putting the value in the, there's no header, there's no overhead, and it's still kind of unboxing. Yeah. So yeah. Martin already said it's okay. Martin.
Yeah.
Hi, Martin.
So Martin also helped us in some translation. You had like erlaubt in the slides. It means
sorry.
allowed.
Yeah. Thank you. Actually, the talk, my English is a bit rusty because I don't have to speak that much English, but it becomes better maybe in the next 2 hours if you speak English. It's a bit easier for me. And I translated the slides because my talks are most of the time in German, so sorry for some forgotten words to
Right. So the next question again from Martin is more about the syntax for the nullable types in general. So maybe if you can go back to that slide. I think there was a question again from Martin. There was
it's about a question and exclamation mark.
I think so, yeah. So isn't Kotlin a regular variable non-nullable, and then bang assumes it's not null?
Can be. I'm not a Kotlin expert. As far as I know, in Kotlin, every reference is non-nullable. And if you have the bang, then it is nullable. But I'm not sure. But I think that can be. Yeah, I'm not a Kotlin developer.
So we probably have that, something that is, I would say, very similar. It would be really a shame that, Kotlin uses the bang for nullable types and Java would use the bang for non-nullable types. That would create like an immense confusion.
Maybe.
So yeah, I really hope
actually this syntax is not final. It's a Strawman syntax, so they can be quite different next year or 2 years when they introduce it. But for me, the bang and the question mark are quite readable. So question mark means it's a question: is it null or not? And the bang is it's not null. So it makes sense, and I think only 5 to 10% of the Java developers know Kotlin. So for the other 90%, it's not a problem because they don't know Kotlin yet. So
yeah. So I have a question, which is more about the fact that if you have basically the value types will be eventually exploded, right? So I think you made one example the one that had the point and the colors and the RGBs and so on and so forth. So even if you have like the outermost object contains only pointers to other types, value types, right? So in itself, it doesn't really have an int as a field, but still points to some other value types. Well, eventually it will be organized in a way in the JVM that will optimize everything. So yeah, if you have enough registers to put all the fields, the objects will eventually be, every register will get a part of the fields that are there. And therefore, you can very efficiently refer to each part of the object through, referencing the right register in the CPU.
Yeah,
so
and of course, the value objects can have reference types, so it's not forbidden to have a reference type inside. So you can have a date or whatever. It can't be flattened then, or it can't be optimized like other value objects, other value types, but it's allowed. It will be allowed.
Also, you correctly pointed out that this kind of optimization are possible by the JVM, but I don't think they are mandated by the JVM, meaning that the JVM may flatten all the objects, but may also not do that. Is that correct?
Yeah. In the beginning, there won't be that much optimization. They have still lots to do to have at least to change the memory layout and the new types to implement all that stuff. And there won't be that much optimization. But from year to year, they will have some more optimizations. Maybe different OpenJDK releases can have their own optimizations. For example, Azul or IBM or whatever for special use cases, and that will be quite powerful then in the next years. So it will be the base to have lots of optimizations which can be possible but are not mandatory. Yeah.
And I'm actually quite excited about this because I've already touched with my own hands the optimizations that came in Java 25 with the compact object headers, and which are actually changing the memory usage by something like between 10 and 20%, maybe in average, because of the reduction of the size of the object header. But here we're not talking about 10, 20% in average. Like in the slides that we see here, we're talking about 8 times less memory. So if you really have an application that works with pixels and color with alpha and everything, that will be like a huge
I think it will be 50% in average. So it depends on your data layout and how you,
I'm thinking, I'm hoping for more than 50%. I can, I can easily see maybe, well, you have to change the code base of your project, obviously, to put the value keyword in front of the relevant classes.
Yeah.
But if you're heavily using, dates and optionals and integers because you have list of int or list of double or something like that, then, you start thinking, okay, well, a lot of benefits already come from the JDK, plus all the benefits that will come from my classes that I have converted to be value types. Wow, that can be a lot more than 50%. I mean, it can easily be twice as fast or twice less memory.
I think that should not be the goal of value objects. I think the semantic meaning of the data type is the more important advantage, and that we have less memory is also cool. But if that we have post zip codes, that we have email addresses, and they are just as efficient like an int or a string or a character array, that will be the big advantage, I think.
Yeah, absolutely. So one last comment from Martin. I think he said, well, I kind of want, I think he's referring to value types, to be a breaking change. And let's do it like in Kotlin and use open rewrite. Sure, but it will not happen. I think Java has a long history of not breaking backward compatibility, so it's fine.
Yeah, thanks, Francois, for your lots of your comments and, and questions. Yeah. Cool.
Okay, so if you have a final words, otherwise, Falk, otherwise we can call it.
The final words can be that if you have any local Java user group nearby, then just go there and go to the talks, go to the events, and speak to the people, learn from each other. That's really cool. And just try value objects with some friends from local user groups, Java user groups, would be very nice. So maybe we see us in Darmstadt or some other local groups.
Yeah. Okay, thank you very much, everybody. And I'm calling it an end to this presentation. Thank you.
Thank you. Bye.